On this question, we're going to determine whether the function is even, odd, or neither. In order to check for even, odd, or neither, we're going to plug in negative x into the function. So for this first one, if we do f of negative x, we'll have 4 times negative x all raised to the fifth minus 3 times negative x. Now, the thing to keep in mind here is if we have odd powers, then if we raise a negative to an odd power, it's going to stay negative. So in this case, it's going to be still a negative after being raised to the fifth power, so that negative would turn that to a negative 4 and an x to the fifth. And then these two, negative, negative, will change that to be a positive 3x. Now what's happened here is that all the signs have changed. In the situations where all signs change, that tells us that it's an odd function. In the case of polynomials such as these. Now if we look at this next one down here and we try the negative x, f of negative x, we'd have 5 negative x raised to the second plus negative x raised to the fourth. And the thing to know here is that we're now dealing with even numbers for the powers, power of 2 and power of 4, and so those always will go positive as a result. So if there's a negative, it's going to change to be positive. So here we're going to have still positive 5x squared and positive x to the fourth. Now that's exactly the same thing that we started with in the original f of x function. Nothing changed. That tells us that in this case it would be an even function. Now this one over here, let's try this one out. We'll do f of negative x be negative x raised to the fifth plus negative x raised to the second plus 2. And so what we'll get is that's an odd power of 5, so that's still going to be negative. That's an even power of 2, so that's going to go to be positive. Now the question is, did all things change or did all things stay the same? In this case, we see some signs changed, but not all. That tells us that it doesn't fit the even or the odd. It's neither even nor odd.